Okay, you guys, I'm going to try to get this up this morning. We're going to talk about identifying and graphing sequences, which is just an ordered list of numbers. All right. To understand a sequence, we have a little problem here, a word problem. A go-kart racing track charges $5, that flat fee that we always get, right? And $2 per lap. So I could say plus $2 every lap. Right, and if you list the charges for 1 lap, 2 laps, 3 laps, and so on, in order, the list would form this, right? $5 plus 2 for 1 lap is 7, and every lap is going to add another $2. Well, until you're done racing go-karts. That's kind of scary to me. I hope those are big laps, by the way. A sequence is a list of numbers in a specific order, and that's all it is. Like this is a list of numbers in order, smallest to largest, going up by 2 every time. Each element in a sequence is called a term. So a sequence has a number of terms in them. And in a sequence, each term has a position number. Now that's kind of important, right? The first position, first term. Second position, second term. All right? In the sequence 7, 9, 11, 13, the second term is 9. All right? So the position number is 2. So the total cost of riding a go-kart is shown below. So 1 lap, right, is 7. Add $2 to get 2 laps is 9. Add $2 more to get 3 laps is 11. This looks like I just added $2 more, so that would be my 4th position, right? This term is 5 and 15. Looks like I add 2, so the next term has a position of 9. And a value of 17 right there. You can use the term and position number of a sequence to write a function. All right. The element function of 2 is 9 indicates that the second term is 9. Right. The second term is 9. Use the table to complete the following statements. The first term. Well, let's look up here. The first term is 7. All right. The third term right here is 11. The sixth term right here is 17. What term is 13? Well, it looks like the fourth term is 13. And what term is 15? It looks like the fifth term is 15. So if we identify the domain of this function, that's all our inputs. So we're just going to list it as a series of numbers. So question, right? Is this discrete or is I'm sorry. There we go. Is this a discrete function? Well, the answer would be yes, right? Every single term is a whole number and there's nothing in between. You cannot pay for half a ride, right? Identify the range. That would be my list of outputs. We got 7, 9, 11, 13, 15, and 17. Just to state, these don't have to match up with each other. They do because both of them are from smallest to greatest, but they don't have to. 1 doesn't have to be right above 7. It's just listing all the elements of the domain in the range. All right. So let's think about it. What does 413? Well, if you remember from the original one, 4 was the number of laps. All right. And 13 was the price. Explain how to find missing values in the table. Well, we follow an add rule, right? Of +2. And there's not much space in there, but all I mean is that every time we move down, we add 2. That is our rule. Explain why the relationship between the position number and the corresponding term can be considered a function. All right. Well, it is a function for a number of reasons, right? No input has 2 outputs. That's what makes something a function, right? 1 will only give me 7. So let's keep going. Let's see if we can cover this whole page. All right, and here we go. Okay. So Now we've got something called an explicit rule for a sequence. Defines the nth term as a function of n for any whole number greater than 0. Explicit rules can find explicit values in a specific terms in a sequence without finding any of the previous terms. So what that means is, you know, if I'm just going to add 2 over on this side, let's look at it. So if I'm going to add 2 right here, what I want the previous term. So to find 4 of 13, I take 11 and add 2. To find my next term, I take 13 and add 2. But there are rules called explicit rules that allows me to skip. I could find 100 or 200. Anyway, so if we write the first 4 terms of here, all we've really got to do is take our function and plug it in. Likewise down here, right? If we made a table of values for 3n squared plus 1, I could plug in a number 1, right, for all my n's and say, hey, 1 squared is 1 times 3 is 3 plus 1 is 4, and I get my output. All right. I can plug in 2 and say 2 squared is 4 times 3 is 12 plus 1 is 13. Likewise, I could plug in 3. 3 squared is 9, 27, 28. And I can just plug in numbers. I could plug in 4, right? 4 squared is 16. 16 times 3 is, well, let's do it. Just so you can see it, it's going to be 48 here. Plus 1 is 49. And I can get a series of numbers. All right? We just made a table substitute the values of n equals, right? In this case, 1, 2, 3, and 4. The first 4 terms are 14, 13, 28, and 45. All right. So how would I find the 20th term? Well, if I was going to find the 20th term, all I would have to do is plug in 20. All right. That would give me 20 squared plus 2, which would give me 400 plus 2, which would give me 402. So this one says the number 125 is a term of the sequence defined by the explicit rule f of n equals 3n plus 2. Which term is that? Well, all I know is that when I plug in a term, right, f of n, out comes 125. So if I take that and I plug 125 in for f of n, I'm going to do it right underneath so you can see. This should tell me what value of n or what term would give me 125. So I can solve this like I normally would, right? 123 equals 3n. Divide by 3. That gives me the 41st term. Now this is a kind of a different way of doing things, right? Because what we've done, instead of plugging in a value for n, we've plugged in an output value, right? And when you have an explicit function, it allows you to go and plug in either input or outputs and solve for values of n. Now, I'm going to take a quick peek at 147. It is right here. There's 2 more questions there. All right, and it says write the first term in the series, so let us do it. We are literally just going to do what we did on the other side. All right, we're going to say this is the term. We're going to write it as n squared minus 5. 1, 2, all right, 3, 4, and here we go. 1 squared minus 5 is negative 4. Over here is our output, or f of n. 2 squared minus 5 is negative 1. 3 squared of 9 minus 5 is 4. 4 squared of 16 minus 5 is 11. And there we have our terms. This one asks us the other rule. He says, find the 15th term of the sequence defined by this. So all I do is, it's asking me to find out what term is 15. So I plug in, because it's explicit function, I can just plug in any one I want, and I can say, let's plug in 15, which gives me 16 minus 3, or 57. So I know my 15th term is equal to 57. Now I'm going to stop here. It's going to get a little bit different here with recursive, so that's a whole new subject, and I'll be right back.